Friends, welcome to Bank Exam Cafe, and in today's episode we are going to see revision of 2 marks questions. Friends, your exams will begin from the 4th of May and therefore we have got 4 months to revise the complete syllabus. So I have decided to start the revision chapter wise and mark wise. So this is today's episode, revision of 2 marks question, and the topic I have selected as linear equations in 2 variables. And friends, this is the part 1. Of course, I will upload the videos on revision of 1 marks questions, 3 marks questions and 5 marks question from each chapter. I also request you to download the PDF file from the description box. Now let us see the first question of today's episode. On comparing A1 upon A2, B1 upon B2 and C1 upon C2, find out whether the line representing following pairs of equations intersect at a point, are parallel or are consistent. Friends, we have studied the 3 conditions. Before doing this question, we will revise all these 3 conditions which we have studied earlier, and that 3 conditions are: A1 upon A2 is not equal to B1 upon B2, then the lines will be intersecting lines and the nature of the equations will be consistent and it will have exactly one solution. It means unique solution. If A1 upon A2 is equal to B1 upon B2 is equal to C1 upon C2, then the lines will be coincident lines and that will have infinitely many solutions, and the nature of the equations will be consistent and dependent. And the third condition, we have seen that A1 upon A2 is equal to B1 upon B2 is not equal to C1 upon C2, then the lines will be parallel and it will have no solution because the lines are parallel and the lines will not intersect, so there will be no solution and the nature will be inconsistent. So remember, when there will be the no solution, the nature of the equations will be inconsistent, and if there is solution, maybe unique solution or infinitely many solution, then the nature will be consistent. So we will solve this equation. Now friends, here the equations are 9x minus 10y plus is equal to 21 and 3x upon 2 minus 5y upon 3 is equal to 7 by 2. So first we will find the ratios, that is A1 upon A2, that is equal to, that will be 9 upon 3 by 2, 9 upon 3 by 2. So 2 will go to the numerator and so it will be 9 by 2 upon 3. So 3 1s are 3, 3 3s are 9, and so it will be 3 2s are 6. So A1 upon A2 is equal to 6. Now we will find B1 upon B2, B1 upon B2, that is equal to B1 upon B2, that is minus 10, B1 is minus 10, upon B2 is minus 5 by 3, minus 5 by 3. 3 will go to the numerator and this minus and minus will become plus, and so it will be 10 into 3 upon 5. So 5 1s are 5, 5 2s are 10. So 2 into 3, that will be equal to 6. So B1 upon B2 is equal to 6. Now we will see the third ratio, that is C1 upon C2, that is the ratio of the constant terms. So it will be 21 upon 7 by 2. So it will be 7 by 2. So which is equal to 2 will go to the numerator, 21 into 2 upon 7. So it will be 7 1s are 7, 7 3s are 21, and 3 into 2, that will be 6. And since it is A1 upon A2, B1 upon B2 and C1 upon C2, all these 3 ratios are equal, then see what is the condition. If the 3 ratios are equal, then the lines are coincident lines and therefore it will have many solutions. And friends, since the lines are coincident, it has infinitely many solutions and therefore the nature will be consistent. Here they may ask that whether it is coincident lines or what, that can also be asked. So we must know all the three things, that nature is consistent, the lines are coincident, and therefore it has infinitely many solutions. Now let us move to the next question. Solve x and y. The equations are 47x plus 31y is equal to 63 and 31x plus 47y is equal to 15. And the given two equations are 47x plus 31y, which is equal to 63, and the another equation is that 31x plus 47y, that is equal to 15. Now here we see that the coefficients of x and y are interchanged in both the equations. When such interchange is there, since the coefficients of x and y in one equations are interchanged in the other, then we add and subtract the equations. So remember here, when the coefficients of x and coefficients of y are interchanged, then we first add the equations and then we subtract the equations to get another two equations, and we solve that two equations. So here first we will add these two equations. So let this be number 1 and be number 2. So here first we will add these two equations. So add 1 and 2. If we add these two, we will get it as 78. Correct? It will be 78x plus this will be again 78y, which is equal to, this will be again 78. So here 78 is a common factor, so divide by 78 throughout the equation and you will get it as x plus y, which is equal to 1. Let this be equation number 3. And now we will subtract these two equations. So subtract 1 and 2. Subtract 1 and 2. If you subtract, the signs will change. So this will become minus 31. So 47 minus 31, that will be equal to 16x. Now this will become minus. So 31 minus 47, that will be minus 16y. And which is equal to, this will become minus because we are subtracting, therefore 63 minus 15, that is equal to 48. Now here the 16 is a common factor, so divide by 16 throughout the equation. So you will get it as x minus y, which is equal to 16 3s are 48. So this will be the equation number 4. Now I solve further to this side. So here we will solve this equation number 3 and 4. How we will solve? Simply add the equation number 3 and 4 so that y and y will get cancelled. So adding 3 and 4, 3 and 4. So if you add this, you will get y will get cancelled and x plus x, that will be 2x, which is equal to, we are adding this 2, so 3 plus 1, that will be 4, and so 2 1s are 2, 2 2s are 4, and therefore x is equal to 2. Since we have got the value of x, highlight this. It is very important step. Highlighting makes the examiner to check the question or the answer sheet quickly. So you have to highlight the important steps. So you have to make your answer sheet examiner friendly. Now put the value of x either in equation number 3 or in equation number 4. So put in equation number 3. So from 3, what we will get from 3, put here as 2. So it will be 2 plus y is equal to 1. Take 2 to other side, so it will be minus 2. So 1 minus 2, that will be minus 1. So we have got y as minus 1. So this is also important step. The marks are given at this step. So highlight this step also. And at the end, you have to write the values of x and y. Therefore required values of x and y are x is equal to what we have got 2 and y is equal to -1. This answer 2 has allotted the marks. So here you will get the marks, here you will get the marks, and after adding whatever you get here you will get the marks. So move to the next question. For what value of k will the following pair of linear equations have unique solution? The equation is that the equations are x minus ky, which is equal to 2, and the another equation is 3x plus 2y, that is equal to -5. These two equations are given and you have to find the value of k so that the pair of linear equations will have unique solution. Now friends, here again I revise the same thing. We have seen that a1 upon a2 is not equal to b1 upon b2, then it will have unique solution. a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2, then the equations will have infinitely many solutions. And a1 upon a2 is equal to b1 upon b2 is not equal to c1 upon c2, then the equations will have no solution. So we have to show that it will have unique solution. So we will use this condition that a1 upon a2 is not equal to b1 upon b2. So first we will find a1 upon a2. So a1 upon a2 will be what? 1 upon 3. Then we will find b1 upon b2. That will be what? b1 is minus k and b2 is 2. So it will be minus k upon 2. And since it is said that the equations have unique solution, then these two should not be equal. Therefore by condition 1 upon 3 should not be equal to minus k upon 2. So therefore we will get, if you take 2 to other side, you will get it as k should not be equal to minus 2 upon 3. So highlight this. You have got that k is not equal to minus 2 upon 3 except minus 2 upon 3. If you take any other value, then that pair of linear equations will have unique solution, and hence the given linear pair will have unique solution for all real values of k except k is equal to minus 2 upon 3. So friends, I hope you must have enjoyed this video. If yes, please like the video, share it with your friends, and do not forget to subscribe the channel. Thank you very much for watching this video.